Hello everybody, and welcome to part 2 of our AU-X1 video series here, and TU-X1 if we ever get to it. So we have the power amplifiers finished except for one thing. As I said in the previous video in part 1A, where I was talking about the transistors, some of you pointed out the fact that the two of the transistors I replaced, the replacement ones I used, were the wrong frequency, had the wrong transition frequency, which was TR16 and TR15. I have since, as I said in the video, ordered the correct Toshiba transistors that belong in here. They should be in probably tomorrow, I would imagine. Actually, it worked out really well. They are only a couple dollars, so it was no big deal. I just totally missed that. So thank you all again. I appreciate all your help on this. But once I get those replaced on here, these modules are ready to go. And as I said, I did just statically apply some power to them to make sure that we could power up the output section and put, these are isolated supplies from one another, kind of, sort of. They share the same ground, but it has one set of rails for the outputs, and then these other set up here to drive the board itself. So again, it would be kind of complicated wiring this all up to totally test it on the bench. But anyway, I just compared this one to the other one. The voltages were all the same. They reacted the same. All the static measurements, resistance were the same. I'm right now, I'm pretty confident that these are going to be just fine. So let's move on to the task at hand now. So at this video, things are looking a little more hopeful than they were the last video. I did find out a few things that were pleasantly surprising. Just to give you an update, this first power board, which is the F2781 board, this is kind of like the unregulated power supply and soft start and so forth, is all on this board. I took it out, completely recapped it, checked all the components, everything looks good, cleaned it up really well, put it back together. So this one's all set. Now I also did this board up here, and that one's recapped, it's done. But more interestingly, and this is the pleasant surprise that I found, is while I was working on this, let me get you up here where you can see, I noticed, so this whole module, this green board in the back here, and the 4 circuit boards that are on the opposite side, this is like the motherboard for the phono section. This has a very complicated, elaborate phono stage on it. It consists of a motherboard and 4 individual boards. There is 1 pair of boards for right and left channel for a magnetic cartridge phono, or I'm sorry, a moving magnet cartridge phono, and then 2 boards for right and left for a moving coil phono. And they're 2 totally different designs, and they're custom designed for each type, way more elaborate than most phono stages, even the ones that do support both types of cartridges. So these, when they work, these should be phenomenal as far as detail and sound and so forth. Now here's the thing, the phono stage is one of the biggest troublemakers in this whole amp. That's the part, from my understanding, that has the most problems with oscillation and so forth. And there were, over the years, there have been some modifications that came out to deal with that and to correct some of that. So if I zoom you in a little bit, you see these capacitors here, and they're kind of connected like in a triangle shape here, and they have these ground wires and so forth. And then you see this resistor that goes through this heat shrink and goes onto this wire that goes up the other way. And then there's, on the other side, you can't quite see it behind the board, but there's another resistor going to this other wire, same thing. And then if I turn this around, you may or may not be able to see it. Let me put some light on the subject. See down in there, you can see that I have a electrolytic capacitor, and then it's bypassed with a mylar cap in there. And there's one on this channel, and then there's one on this side, same thing. Those actually, now I recapped those, but actually those were added a later date. So anyway, long story short, a lot of the mods seem to have been made on this, and maybe we're going to luck out after all. Okay, I'm behind this camera again, so I'll do my best to try to reach around everything. But here's the thing. We have the 2781 board recapped. I did not, however, recap the main regulated power supply, which of all places is actually mounted up front here near the line stage board and so forth. It's right up in the front. We're going to have to remove it as a whole module, and it's got all kinds of components on it that we're going to have to go through. But I think we're safe enough. I did ESR tests on a pretty big sample of all the caps that have come out of this thing so far, and so far not even one of them have been bad. Those black Mylar caps, there were several of those that were really bad, but all as far as the electrolytics go, they're all still pretty good, and they're all high quality Nichicon and Elna capacitors, so I wouldn't have expected them to be really bad. This is really just a future proofing thing, recapping this amp. It probably would have gone for, you know, several more years to come without any problems, but of course you never know with caps. You know, when you start using this amp heavily and start applying power to them, sometimes the caps will reform and they'll last longer. Sometimes they'll fail if they're drying out. And you just don't know that with old caps. So I'm doing it. So, because once this is out of my hands, you know, I don't want the next person that has it to have to deal with it later. So anyway, we're going to power this thing up. And really all we're going to check right now is this board. And essentially make sure the thing powers up, that the soft start clicks in, that these big cap banks up here, and I'll come up and show you a little better, those ones are coming up where they should be. And let me adjust the camera just a little more here. I want to keep the meter in there. And if that all comes up, then we can be pretty confident that we're going to be okay with power. And then we're going to start moving on to the main regulated power supply board. So we're plugged in. I do have my current limiting bulb in there, my dim bulb tester. And no, it's not this one. This is something else I'm going to show you in just a minute. So let's turn the power on. You'll see some light coming up from the side as this thing charges. There you go. And this thing's really slowly charging, which is good. And I did hear this kick in. So that's good, and the bulb has gone pretty dim now. So now what I'm going to do is I'm going to kind of reach around the camera here and try not to electrocute myself. Wouldn't that be fun? And let's test our voltages. So there's our positive 48 there, and negative 48. And once again, we're going through this light bulb, so you're not going to have full voltage. So there's that, and we have positive 48 there, negative 48 there. So at least we know the main DC rails are coming up. And I have to think that the feed power coming off of this board up to the main one, they're probably going to be okay too. None of these fuses are having any problems. I think we're going to be okay. So let me shut this back off. And I'm going to just show you a couple methods to discharge these caps. Now remember, first thing you want to do is unplug the amplifier after it's powered down. This thing will still give you a horrific shock, especially some of these amps that have the big DC rails, you know, like the plus and minus 70 or 80 volts, because that's plus and minus 70 and plus and minus 80 volts or whatever. But if you get across the whole line, it's those two added together. So it's 160 volts or 140 volts. That will wallop you really hard, especially with those capacitors like that. So what we want to do is we want to discharge the caps to make them safe. Now if you just shorted them out, number one, you'd probably melt your screwdriver or whatever you use, and that's very hard on the chemistry of a capacitor. So we want to discharge them fairly rapidly, but we want them to dump their power into a resistive load. Now there's two ways to do it. The first one you've seen me use many times, which is this stinger cable, which consists of a resistor. And this resistor, one side of it is soldered to this brass rod, and it's heavily insulated. The other end of it does not go on the brass rod. It attaches to this wire. So essentially when you connect this wire to ground and you touch this to any of the voltages, it will discharge that capacitor through this resistor. And this is like a 10-watt resistor, and it's probably around 100 ohms or so. And it works really well on high voltage supplies, you know, like for vacuum tube amplifiers, like the 450 volt caps, because they're usually a much lower capacitance than a solid state amplifier. So really, it reduces the voltage very rapidly through this, and doesn't really give this, this doesn't see surge current for very long. However, when you get into these great big capacitors, especially 80,000 microfarads like you have here, what ends up happening is it takes too long for this to drain that current off. In other words, the high current is going to be across this resistor for a much longer period of time as that capacitor bleeds down to a respectable level, which is going to heat this up. So if you discharge multiple caps with this thing, you're going to find out that this thing's going to heat up on you. It's not going to hurt you or anything, but it's going to heat up, and eventually it could open the resistor. So another method is to get yourself a little light bulb socket like this one, with little terminals on it, and just get an old cheap set of probes and just cut the wires off and crimp some fork terminals on there. This is just a rough service light bulb. Okay. I also really like to use bulbs out of stop lights, out of the traffic signal lights. You can buy those at electrical supply houses, and they're not very expensive, and they're extremely durable. But anyway, we're just going to take this bulb and short it across the capacitors, and I'll show you what it does. It'll nice and gently discharge the caps. So watch the bulb. And you can see how it just drained it down. Now it's drained. Now we're going to take and do this bank. And you can see there's no big arcing, sparking, nothing like that. It's very gentle. And it drains the caps. And then we'll do this side. And you can see all that while we were talking, this thing was sitting there holding that charge. And the strange thing is, this amplifier has not been powered up for a couple of months. It's been sitting here in my shop for a month or two before I could even get to it. And when I checked, this bank of caps on this side actually had charge on it. And this thing had never been plugged in. And you'll find that these things can do that. They can build a residual charge on them just sitting there. So you always want to check these before you do anything. Now, the residual charge might only be, 5 or 10 volts. It won't hurt you if you touched it. But when we just had it plugged in, that could have hurt you. So now it's all nice and discharged. As you can see, nothing's coming back now. It's good. And these are all nice and discharged. And that's a very inexpensive, this is only going to cost you a couple bucks. This is a plastic base. And this is a cheap, incandescent bulb. And just extra probes I had off of one of those, dollar store meters or whatever from something. And you can make yourself a nice discharge unit. So now that we're discharged, we can continue our work. So just thought I'd show that to you. Okay, we now have the F2778 regulated power supply board out of the machine. And you can see what a mess we have right here. So if you look down in here, for instance, you see just how corroded some of this stuff is. Right there's a bad one down in there. Down in here, these are all corroded. This one here is really corroded. You see it? So it's that glue once again, and you can see it is just everywhere on this board. So this whole board's going to need stripped down and just cleaned. And I probably won't get all of this glue off of here because it damages the board when you do that. I will just remove the glue that comes in contact with any of the components. And then if there's a little bit in the open area of the board, I'm just going to leave well enough alone. So, well, I guess we just need to start working. And you can see these caps down here, right in here, right there. You see how it's like coming apart? So these caps are getting ready to fail. If they haven't already, I don't know. But most of it is just from that glue. So let's get to work and start recapping. Okay, a little update here. We have this side of the amp done, and I'll tell you what, there's a good 2 to 2.5 hours just in this little section here. I can't tell you how terrible that corrosive glue was. It was just on everything. Just everything was just crusty, covered with it. You can kind of see what it does. And like even these film capacitors that normally don't have any problem, you notice they didn't fit on the board properly, and the board was originally fitted for electrolytics, and somebody had replaced them with these. It was a factory thing. And that glue, they had glued these to the sides of the electrolytics that were next to them. You could see I replaced them with these little film capacitors here. But they were actually originally glued like that. And the glue has actually kind of broken down on the side that you used it. This is like real mushy now and soft. So they got replaced. Just cleaning all this just took a long time. Some of these resistors were so badly corroded that the corrosion had actually gone through the circuit board and onto the back of the solder pads, and I literally could not get them to melt to remove them. I had to first clean all the oxidation off to even be able to melt the solder enough to get the resistors out and replaced. Some of the leads just kind of broke off just as I even touched it, just because they were so corroded from that glue. But this was definitely the worst side, and this is definitely going to be the part of the restoration that will take you the longest if you're going to do one of these, because there's a lot of components on here. I would love to know the total number of microfarads. If you took all the microfarads of all the capacitors in this entire amplifier, how many microfarads? Well, it'd probably be farads by how many are on here. I mean, you just look, this thing by itself is just loaded. Each one of these is 1,000 microfarads. All of these are 1,000 microfarads here. They're just, I'll tell you what, they really wanted this thing to be filtered, I guess. The other thing I noticed was these pots, all 4 of these pots were maxed out in one direction. So either it was not properly adjusted, or some of these components were bad and they were trying to compensate for it by maxing out the power supply. I don't know. We'll find that out after we get this all back together and start testing it. But there's a little update for you. Okay, so I have the power supply all finished and put back together, and where I'm feeding plus and minus 16 volts into the first supply, which is this one up here. And if you look, you're coming into pins 19, 21, and 20, which is back here, and 22, 14, and 23. And you can see TPO1 right there. And here's your pot to adjust it. I see now why they had this thing maxed out. The pot's maxed out. I too have the pot maxed out with 16 volts going in, and I'm really only getting plus and minus 10 volts here and minus 10.7 volts here. So we're not getting our 11 volts. And so now we have to troubleshoot and find out why that is. And I have a feeling probably there's some more problems with some of the components on this board from that glue or something. Who knows? But let's kind of step through this and we'll troubleshoot this first one and try to see if we can find out what's going on. Okay, we got that one fixed. There you have it. And it was a plethora of things. Let me go down and show you. So first thing, I replaced both of these transistors, this one and this one. And by the way, you have to have a load on this. I have a 150 ohm resistor on each one, and that's bringing about 80 milliamps through the circuit for plus and minus. So these transistors both tested good. That's a C1845 and an A992. They test perfect. Gain is good, no leakage, so forth and so on. But when I replaced them, it made a difference. And another thing I ended up having to do was this was a 5.6K resistor, and I had to change it to a 4.7. And then it gave me the amount of adjustment I need, but it was still a little bit out of balance. So all I did was this 10K, these two resistors had been replaced, this 10K and 1K, because they were so corroded and ruined. And this one here was in good shape, but I ended up replacing it as well, and that balanced it right out. Now it's perfect. So we're going to have to do that to all the rest of the supplies on here and make sure they're all working and that they're all adjustable. And these are very temperature dependent. So, if you change the temperature of these transistors, the power supply will drift a little tiny bit. And you have to give them a second, a minute or two to warm up before you can adjust it. That's the way these old linear power supplies work. So everything should be good now. We're going to move on to the next ones. And again, all of these pots are maxed out, so I'm assuming that all of them have similar problems. That's why you have to go through sometimes and just shotgun these and replace all the transistors, because even though they may test good in your tester, unless you put them under load in real world conditions, you really don't know what they're going to do. So let's go to the next power supply, and I'll go through and do that to the rest of them. Okay, now this is really bizarre. So if you look on here, you can see where it shows the direction of the diode, but they've bodged a capacitor in here, and then they put the diode onto the capacitor. But look, the diode is actually backwards from the symbol. So you can see here's the stripe, but here, and it goes into this, and the non-stripe goes to here. So you can see anode and cathode are reversed from the silk screening on the board, and it's like that on every single one of these. So here it is again, and there it is there. Every one of these is like that. So whatever it is, this is some sort of a, I don't know, whatever you want to call it, an update, or I don't know. Same thing here. Look. There's cathode, but here's where it's pointed on the board. So, well, it worked like this, so this is how I'm going to replace it too. So, there we go. I find it ironic that one of the reasons that they state for the advantage of having a direct coupled amplifier is by removing all the capacitors and not having all these capacitors in the circuit to cause distortion and noise and so forth. Okay, before I put everything back together, here's the finished product. Got all the caps replaced, fixed the bottom of the board, got rid of all that nasty flux and all that. I relocated those, you could see how tiny the replacements for those black capacitors are. And what I did on these that had the diode bodged across the capacitor, by the way, that's on the schematic that way. That's how they show it. But I put the diode on the back of the board and then put the capacitor on the front. It looks a lot neater that way. I think it'll be just fine. And then, of course, here's the power supply board. It's all mounted up and reinstalled. So I'm going to get the faceplate back on, and this thing will be ready to do a little bit of a power test. Okay, so as you can imagine, all these little grain of wheat bulbs, probably half of them were burned out. And those are for the little mode indicator lights. So what I did was I retrofitted them with LEDs, and actually the holes were perfect spacing for a standard, what is this, 7mm or 6mm LED, the standard one, or maybe 5, I don't know, but the standard LED. And what I did was on the back, I cut the track just like for the ground. There's one common ground for all of them. And I cut the track and I put two 220 ohm resistors in parallel just to run cooler. So that gives you 110 ohm dropping resistor. And half of them are fed through this resistor and half of them are fed through this. That way, if two lights, I think there is a situation where the top bank and bottom bank can have one light on at the same time. So that way, that takes care of it. So that's all there is to it. I'm going to get this mounted in there and we'll have LEDs. Okay, time for Tony to get schooled by this thing, the abominable amplifier. So the first thing I did after I got this all set up, I adjusted the power supplies. They came in perfectly. And bottom line is the right channel, I don't have the power amp modules in, and I don't have the phono stage amps in. The only thing I'm running right now is the flat amp. And we're just making sure that we can put a signal into the input jacks, like the auxiliary or tuner input, and we can make the output, the actual drive signal that would go into the power amp modules, come out. On the right channel, we were having no problems. On the left channel, however, flatline, nothing. So I got to troubleshooting a little bit here, and just real quick. And let me turn this on for a minute, and I'll kind of show you where we are. So I'm going to move you over to the scope for just a second. Now, the waveform that you're seeing on the scope over here, and you're going to have some glare because I have the lights here on the board, but that channel right there, the yellow, that's the good channel, that's the right channel. The left channel, however, and basically whatever is on these two test points, you have TP02 and TP01 in there. Whatever is on those test points is pretty much what the signal is going to look like going into the amp modules. So I'm going to take on this TP02, which is the left channel, I'm going to connect my scope probe to that, and the blue trace up there should show us a signal. And if you look, it does not. Now, if I go to the TP01, you can see I have a good signal there, a nice strong signal. If I go to the same volts per division, you can see. But if I go to the other channel, nothing at all. Now, conversely, I can go into the input here, and I can measure the two gates of this FET pair, and I can see it goes into, but not a goes out. So let me show you that here. So if I go to the gate of the first FET, you can see I have a small signal there. It's not much, but I have something there. And if you compare that to the other channel, same thing, right? It's not amplified yet. That's why it's smaller. If I go to the gate of the other FET, you can see there is nothing there. Nothing at all. But if I go to the gate of the other one, the other channel, you can see I have the same signal on both gates. Now this may lead you to believe that that FET is bad, but you have to take it a little bit further before you can make that determination. I'll show you the schematic again. And I'm doing this lazy man styles, but so I'm in the middle of troubleshooting. But if you look right here, you have this transistor down here, and it's just a 2SC1845, and it feeds the balance to these down here. This is actually your, what do they call that, a current sink or whatever. This sets up that voltage level right here that you're going to use to balance the two FETs. If you check there, long story short, I do not have my signal down there either. You can see everything is just reading off the scale. Whereas on the other channel, I have my signal. So I dug a little bit deeper, and I'll show you where that transistor is here. So the transistor that we're looking at is right in here. You see it right there. I'm pointing to it. And it has a emitter to base dead short. So it's shorted. It's a bad transistor. Now, another thing that I will show you just how unstable these amplifiers are. If I take this probe here and put you back on the scope, if I even just touch the base of that transistor, it does that. It goes into wild oscillation, and sometimes it'll actually flatline and go into high frequency oscillation, and it'll take it, if I take the probe away, it'll take a second or so for it to stabilize again. It's very sensitive in there, and that's part of what they're talking about with these things. And strangely enough, I don't even have the negative probe of my voltmeter. I have a digital voltmeter, high impedance input with no ground connected, and I'm just touching it with this probe that's really not connected to anything. But it's just very sensitive. Now that's normal. Some of these circuits are that sensitive because of the high gain, but usually they're stable enough that when you take the probe away, the problem goes away. These ones kind of maybe not. So that's where you can get into, you have to really be careful with all your grounding and everything. Those capacitors have to be correct and have to be in place, or you can really, this thing can run away from you. So guess what? We get to take that amplifier, or that flat amp board, back out and replace the transistor. And I thought about just replacing all the transistors on that board, but they all looked to be good. I didn't see any problems. The machine was working at one point in time, I think. At least that's what was told to me. But we're going to replace them. I mean, they're 50-cent transistors, so we're just going to do them. All right, back to work. Well, what do you know? Two really pretty looking waveforms. So, all right, time for a confession. It's easy to really just edit this stuff out and pretend it never happened, but that wouldn't be too fair to you guys. I think when we make mistakes is when we can learn the most. So I'm going to show you a couple things that caused me to kind of go down a rabbit hole for a minute. Number one, the shorted transistor. If you notice on this meter, it's not like a lot of the other meters. In order to go into diode check mode, you have to press these two buttons together, which I had. However, I was still set on voltage. And if you're still set on voltage, you have to be on ohms for this to work. So that was a wardrobe malfunction on my part, I guess you could say. But that was not the real problem. Let's look at what the real problem was. If you look down inside here, underneath these two resistors, there is a Zener diode. It's a 6.2 volt Zener. Exactly like the one on the other channel over here. And you can kind of see it here in between these two resistors. Like if I pull them apart, see it? Right there. And it just so happens that remember I told you I put those Zeners on the opposite side of the board to make it neater. I put this Zener in backwards. All the other ones were in correctly, but that one was in backwards. And of course, when it's in backwards, it can't do its Zener thing. So now that we have that corrected, everything's working fine. And I think we're ready to kind of go to the next level here. And I'm going to, first of all, I think before I go to the phono stage, I'm going to clean all this up back here. Clean the contacts and, do the maintenance back here. Then I'm going to go and we're going to do the phono stage and test that. And once we're sure that the phono stage and the flat amp, all of that is working perfectly, we're not getting any crazy oscillations or anything like that, then we're going to carefully install our power amps and see what we get. Alright, well, we're finishing up the speaker relay board. It has the Zobel network on it and 2 protect relays, and then your speaker leads. And you can see the kind of bodge job they did here, because they removed the coil from here and put the larger coil down on the bottom of the amp module, if you remember. So I'm going to fix this, make it a little bit nicer. And I just wanted to show you, a lot of people want to replace these speaker terminals with newer gold-plated ones. The problem is with most of the gold-plated ones today, the gold plating is like a couple microns thick, and it's first time you tighten it on the wire, it'll rub the coating off. But this one's the real deal. It actually has silver in it, and they're very well built. And you can see with just a little bit of polishing how they cleaned right up. I mean, really nice. And these, with the silver even the hardware is silver plated, and so this will make extremely good contact. So these are good speaker terminals. They do not have the banana plugs on the back, but really I'm kind of a fan of take your copper, put it right in there and tighten it down, the old school way. And you can see the nice insert bushings in here. I mean, these are very well made. So I cleaned them up. I just wanted to show you this last one before I installed it. They're really good quality. So let me get this last one in and we'll continue on. And so ends part 2. We have the faceplate put on, and this faceplate by itself is solid metal, and it probably weighs more than a lot of Class D amp modules that I've had out there. This thing weighs a ton. But it's all together, and we're going to end this part right here. And as you can see, we got this all together. I did not change these relays back here. Those are, again, those really high quality ones with the bifurcated contacts and so forth. I'm not going to mess with them. They're good. Everything's put back together. I cleaned up the wiring mess on there. Kind of cleaned everything up in there. And when we go to part 3, we're going to start tackling the phono stage and hopefully get some sound out of this amp. So again, thanks for coming along for the journey on this one, and I wish you all peace, joy, happiness, and good health in your lives. And we'll be back real soon. So, end of part 2. Bye-bye.